Right, this video is going to be about potential dividers. Really simple thing. You just need to know what they look like and how to do the maths for them really for your exam. Not a great deal. They're dead easy to spot. You should all know by now that if you have a rail along the top like that, we call that positive. This you'd call 0 volts or negative maybe. And a potential divider is easy. If you ever see a resistor stuck on top of another resistor and they're joined together in the middle, one end of one resistor goes up to positive, the other resistor goes down to negative, and there's a line coming out of the middle of the two, that is a potential divider. The thing I have a box around now is a potential divider. Right. Do remember, if you saw something like this, let's put an LDR there, delete that. That is still a potential divider, okay? It's a light dependent resistor, so you've still got two resistors, one on top of the other. You could also have this arrangement, and that would still be a potential divider. You've got two resistors yet again with a line coming out the middle. So I'm hoping by now you've got the idea of the pattern. Now, the whole point of it is to divide potential. If you remember, potential is, well, it's short for potential difference, which means the same thing as voltage. So if we've got 9 volts of potential here, that's like the amount of push we've got for the electricity. This will divide up that voltage, and I can kind of prove that if I put a voltmeter across it. So let's go get a voltmeter. I'm going to stick that in there like so. Connect one end to the thing I want to measure and the other end to ground. This would be connected in parallel. That's what we've done there. If I press play, I'll see that I've got 9 volts going in and 42.92 millivolts coming out. And if I change one of these resistors, say this variable one here, make it bigger, you'll see the potential, or the voltage, is changing. It's being divided. Okay. The light sensor does the same. I might be shining different amounts of light on it, but it's actually changing resistance as I shine more light on it, and you can see that has an effect on the voltage. So you might be thinking, well, that's great, Mr. Winter, but why are you telling me this? Well, because you need to know it, firstly, and secondly, it's also very useful, a really core concept of electronics. We can use it to get a voltage that we want. So I wanted to power a PIC chip, right? So let's go get a PIC chip. If you know anything about PIC chips, if you remember them, you cannot run them off more than 4.5 volts or they get blown up basically. So what I could do is I could make a potential divider. Ignore what I just did then. I can make a potential divider. I don't know why it's done that. It wants me to make a flowchart. Bear with me a second. Imagine I had a PIC chip. Well, let's just say this particular chip here could only handle 4.5 volts. I can arrange my potential divider to give me 4.5 volts, even though I'm putting 9 volts in on my battery, and then what I would do is connect that up to the positive of my chip, okay, and I've got a voltage that I want. And you might think, well, that's great, but if you were designing your circuit properly, you'd just use a 4.5 volt battery to start with. Well, yeah, you could do that. So you might want to think of another use for a potential divider, and that could be as simple as turning on a thing called a transistor, okay, which is an electronic switch. So I'll show you how that would work. If we get a transistor, one of these types here, we call that a bipolar transistor, 3 legs, and it works like a switch. I'm going to get an LED. This is the thing I want to switch on, okay, and I'd connect a transistor up like this, again standard. It gets power from the battery, the other end of it goes to whatever you're trying to turn on, that's called the emitter, the LED goes to negative, and then the base goes to our potential divider. Now, what you'll see here, if I just press play, as I make it darker, you'll see the light goes out, okay. Now, to explain why that's happening, I need to put my voltmeter back in, which is under here. Connect my voltmeter up and just see what's happening with the volts. Now, as I make it darker, can you see that if my voltage is anywhere below about 1.7 volts, my LED doesn't come on, and at a certain light level it does. That's because of what my transistor's doing here. This is an electronic switch, so unlike a normal switch where you would flick something, you'd physically press it to turn it on, the transistor switches on when it gets a certain voltage appearing on this leg here, the one that I'm kind of trying to draw a box around. There you go. This leg here called the base. Okay. When it gets a particular voltage there, it opens up a pathway inside itself. It starts to conduct, and what happens is the diode, the light emitting diode, can get its energy out of the battery. Okay. When this isn't conducting, nothing flows through there. All right, and you can see that if we look at current flow. If we press play, when we're in darkness, there's no current flowing. When I move into lightness, my potential divider changes, and you can see the dotted lines moving, which means current is starting to flow. Okay. We have to have that because we have to have the correct voltage on there. You might think, well, why couldn't I just put my LDR straight onto my LED and control it that way? Okay. You'll notice that doesn't work. Okay. It comes on at one brightness only when there's next to no resistance, and actually in reality we'd end up blowing up our LED if we did that because it would be getting too much. Alright, not a very useful circuit. If we go back to what we had, press play, we get the LED coming on at the light level we want. We have this variable resistor down here to allow us to calibrate the light level we want. Okay. So if I make my resistor here smaller, it now has to be a lot lighter for my LED to come on. Okay. If I make my resistor a lot bigger, I now need hardly any light to switch on my LED. Okay. So the two of them work together, they balance each other, and they divide up the voltage, hence why they're called a potential divider. Remember, this thing needs more than 1.7 volts to send electricity through it. That's the whole point of it. Now, for the math side of things, you need to know the formula, which is just here, which is given to you. And the formula is always the same. It's given to you in the exam paper at the back, you've just got to know how to use it. So if we pick a potential divider here, we've got a 10k resistor, another 10k resistor. The top one's always called R1, the bottom one's always called R2. VS means voltage signal, which is the one you're trying to measure or find out, and voltage in is however many volts you've got on your battery. And it's dead easy to work out. So this formula, R2 would be 10k, R1 is 10k. So we would put in these numbers, it would be 10k over 10k plus 10k times 9, because that's the volts in. Remember, k means 1,000, so I would stick 3 zeros on if you're not good with your calculator. So it's actually 10,000 divided by 10,000 plus 10,000, times that by 9, and you get 0.5 times 9, sorry. If you did this little bit first and then times it by 9, you'd get that. And in total, you get 4.5 volts out. So what we're saying is, with two 10k resistors, we put 9 volts in, we get 4.5 volts out. Okay, that's also a good idiot check to use in your exam. It's always the same. If this resistor and that resistor are exactly the same value, doesn't matter how big or small they are, you will always get half of the supply voltage coming out. Okay, so if the supply is 9, with that arrangement we get 4.5. If the supply was 10, we'd get 5 volts coming out. If it was 15, we'd get 7.5 coming out. There's always half. Even if they were a million, thousand, bazillion k each, you always get half coming out. Okay, that's potential dividers. So in summary, the two reasons you'd want them are you can create any voltage you want, which might be useful for components that need a particular voltage and don't want too much or they'll blow up. And the second reason is you can use them to sense things. Could be temperature, could be heat, could be light, could be just turning a variable resistor, okay? And if you connect them up to a transistor, they act as sensors because they create a varying voltage that is what you need to use to switch on a transistor. If you're a bit confused about the whole transistor thing, check out the transistor video. That'll go over it slowly in more detail.